Hi, in this video we are discussing the 10th numerical from the exercise for the chapter Units and Measurements, which is the first chapter for 11th standard physics. So let's get started. Now question के starting में ही हमारे पास एक बड़ा equation है which goes like V is equal to AT plus B upon T plus C plus V naught. And question में हमें ये भी बताया गया है कि this particular equation is a dimensionally valid equation. Now what do we mean by dimensionally valid equation? Well, हम जब ये question solve करेंगे तब हम ये चीज़ explore करेंगे. But for now, let's move on with our question. और फिर हमसे पूछा गया है to obtain the dimensional formula. So basically हमें dimensions ढूंढना है of certain unknown quantities. What are these unknown quantities or unknown terms? Well, our term A, B and C are the unknown terms और इन terms के dimensions ढूंढना है. क्वेश्चन में आगे हमें यह भी बताया गया है कि these apart from these unknown terms there are certain terms which are known to us. So जैसे कि term v represents the velocity, term small t represents the time and term v naught represents the initial velocity for this particular equation. So हमारे equation में कुछ known terms है और कुछ unknown terms है और हमें जो है unknown terms के dimensions ढूंढना है. So that is what our question is about. So let's get started with the solution of this particular question. So हम हमारा solution का section बना लेते हैं. So solution में हमें basically all we have to do is use certain conditions for dimensionally valid equation and then we can comfortably calculate the dimensions of the terms. ठीक है, तो the first thing जो हमें करना है is I'm going to write the equation in the solution. So we have the expression V is equal to AT plus B upon T plus C plus V naught. ठीक है, and using this expression हमें बोला गया है first हमें ये भी बोला गया है condition that this is a dimensionally valid equation. So let me just mention this condition quickly. Valid equation. ठीक है, so this is a dimensionally valid equation. The first task हमारा जो होगा that is to calculate the dimensions of term A. So let's get started. So as per the equation, since the equation is a dimensionally valid equation, I can say that all the terms on RHS must have identical dimensions, with the term on LHS, So one of the basic principle of dimensional analysis या dimensionally valid equation is कि हमारा जो भी LHS का dimension होता है that is identical to dimensions of all the terms on the RHS. So हमारे जो ये इंडिविजुअल टर्म्स है जैसे AT एक इंडिविजुअल टर्म है, B अपॉन T प्लस C एक इंडिविजुअल टर्म है, V नॉट एक इंडिविजुअल टर्म है ऑन दी राइट हैंड साइड ऑफ आवर इक्वेशन. इन सब टर्म्स का जो डायमेंशन होना चाहिए दैट शुड मैच विद द लेफ्ट हैंड साइड ऑफ द इक्वेशन का डायमेंशन. और लेफ्ट हैंड साइड पे कौन सा टर्म है? दैट इज वेलोसिटी. तो लेफ्ट हैंड साइड पे हमारा डायमेंशन है डायमेंशन ऑफ वेलोसिटी. सो अगर हम इससे कंपेयर करें सो देन वी कैन से लेट मी जस्ट सो वी कैन से what do we can say? Well, we can say that the dimension of term A into T must be equal to the dimension of term V, which is the LHS. अब यहाँ पर A unknown term है but small t एक known term है and we have to calculate the dimension for A. So dimension for AT can be represented as dimension of A into the dimensions of T, which is equal to the dimensions of our velocity. So therefore finally I can say dimensions of term A is dimensions of V divided by the dimensions of small t. Now we know velocity ka dimensions. It is easy to calculate distance upon time. So velocity ka dimension is given to us as L to the power 1 and T to the power minus 1. And small t ka dimension is same as that of time, which is T to the power 1. If we were to solve this further, इससे हमें जो है हमारे फर्स्ट अननोन टर्म दैट इज a का डायमेंशन मिल जाएगा, विच इज l to the power 1 and t to the power minus 2. And this is the first part of our numerical, that was to calculate the dimension for term a. So हमें term a का dimension मिल गया है. Now let's calculate the dimension for the other two quantities, that is b and c. Now अगर आप देखोगे यहाँ पर तो term b के dimension calculate करने से पहले it's important for us to calculate the dimensions of c, because term b का dimension is dependent upon the dimensions of c. So हम flow में अब calculate करेंगे हमारा second part, that is to calculate the dimensions of term c, which is unknown to us. Now since हमारा जो native equation है, that is v is equal to 𝑎𝑡 plus b upon t plus c plus v naught, is a dimensionally valid equation, we can also make one more statement. So dimensionally valid equation की एक और property होती है, that any term that is added or subtracted, ठीक है, सो कोई भी एक टर्म होगी जिस पर हम एडिशन या सब्ट्रैक्शन का ऑपरेशन लगाएंगे, these terms must be dimensionally identical. So any term that is either getting added or subtracted, so these terms must be dimensionally identical. If let's say AT is getting added with V naught, so AT और V naught का dimension जो है वो match करना चाहिए. Similarly, if you observe this particular setup over here, if small t is getting added with c, so यहाँ पर small t का dimension और c का dimension match होना चाहिए या identical होना चाहिए. That is the property of a dimensionally valid equation. So from this we can say that the dimensions of our unknown term c must match or must be identical to the dimensions of our small t, which is time. So from this I can say that dimension of c is dimension of time to the power 1. So t to the power 1 is the dimension for our second unknown quantity, that is c. And now that we have calculated the dimensions of c, we can use that property, we can use that dimension to calculate the dimension of our term b. So let's get started. Okay, so now our task is to calculate the dimension of our last term, that is b. So we have seen two conditions for a dimensionally valid equation, and from this we can say that the dimensions of terms on RHS, so dimensions of term on RHS is b plus t upon c, is equal to the dimensions of the term on LHS. That is a property of a dimensionally valid equation. So b is a term on RHS side and v is the term on the LHS side. Now if we were to solve this further, we get dimension of term b is equal to the dimension of term t plus c is equal to the dimension of term v, which is velocity in this case. Now dimension of term t plus c is going to be the same because it's an addition. So the effective dimension is going to be the dimension of time, so that is capital T raised to 1, and dimension of v हमने already calculate किया था, that is l to the power 1 and t to the power minus 1. Now if I need to calculate the dimension of our term b, I need to send our term t raised to power 1 in the RHS. So if it is in the denominator on LHS, when it goes to RHS, it goes into the numerator. So dimension of term b is equal to t raised to power 1 into the dimension of l to the power 1 and t to the power minus 1. And upon solving using the laws of indices, t to the power 1 cancels out t to the power minus 1. So we get the dimension as l to the power 1. So this is the dimension for our term b. And with this, we have calculated the dimensional formula for all the three terms, that is a, b, and c. So the dimension for term a is l to the power 1 and t to the power minus 2. The dimension for term c is t to the power 1, and the dimension for term b is l to the power 1. With this, I hope you understood. Thank you. If you want the PDF of the solution, make sure you check the description.